There are several properties of electrons, such as mass and charge. These quantum numbers that we're talking about describe an electron's relationship in the atom. The electron's distance from the nucleus, the shape of the path of the electron, and the direction of the path of the electron. This fourth principal quantum number, the magnetic spin, it's the physical reason why we observe the maximum number of electrons that can fit in an orbital. To talk about the orbitals a little bit, and that fact right there, we have two main shapes of orbitals that we're going to concern ourselves with in Gen Chem. The first one is an s orbital that is spherical in nature. And the second one is a p orbital that has this dumbbell shape, or a shape of two balloons tied together. And the direction of these p orbitals, one is in the x-axis, one is in the y-axis, and one is in the z-axis. Now, something I need you that's very helpful if you commit it to memory now rather than later, is the number of electrons that can fit in an orbital, and that is dose. There can be less, but there can never be more. In this s orbital here, the max electrons that can fit are 2. So to put a little bit of perspective on it, this could be a 1s orbital or a 2s or a 3s. The nucleus is in the center here, and those 2 electrons are confined to this shape around the nucleus, buzzing around at 99% the speed of light. In the p orbitals, I have these 3 p orbitals just kind of randomly drawn in here. The nucleus is in the center. And the 3 p orbitals are overlaid around the nucleus in this fashion. That's the Y I drew. Here is the X. And the Z is coming in and out of the board. The maximum number of electrons that can fit inside any one of these orbitals is dose. So 2 electrons plus 2 electrons plus 2 electrons. Got a little away from myself. What the heck is magnetic spin? We can imagine, why is it 2? And the reason why it's 2 is because of the magnetic spin of an electron. Physically, a way to describe the magnetic spin is, imagine the electron as being a tennis ball, a perfect sphere, or a point charge. That tennis ball is going to spin either clockwise or counterclockwise. Now, the direction that electronic negative charge electron spins induces a magnetic field around that electron. What we know and what we've observed is that if you have an electron spinning, say, clockwise, that the other electron will spin in the opposite direction, counterclockwise, inducing a magnetic field of opposites. We give these a +1/2 or -1/2 designation here. This is very much quantum mechanics, not very much touched into Gen Chem. I don't know how much more I can really talk about this, and I'm sure someone can say, like, hey, this arrow actually is the negative, this arrow direction. Okay. But this is the physical reason why only 2 electrons can occupy an orbital at the same time. Thank you.